1. Define the Earth's crust. Explain its major characteristics with reference to thickness, density, temperature, and composition. 2. Differentiate between the continental crust and oceanic crust on the basis of thickness, density, and rock type. Give examples. 3. Describe the structure of the crust with reference to Sial, Sima, and the types of rocks present. Why is the classification of Sial and Sima considered outdated today? 4. Explain how the crust is related to endogenetic processes like folding, faulting, and volcanism. Give suitable examples. 5. The crust is the thinnest and lightest layer of the Earth. Yet it is the most significant for life. Justify the statement with examples. 6. Why is there a difference in thickness between oceanic crust and continental crust? Explain with special reference to mountain systems like the Himalayas. 7. Discuss how temperature and density vary with depth in the Earth's crust. What effect does this variation have on geological activity? 8. Write short notes on a. Sedimentary cover of the crust, b. Igneous and metamorphic rocks in the crust. Q1. Define the Earth's crust. Explain its major characteristics with reference to thickness, density, temperature, and composition. Definition: the Earth's crust is the outermost solid layer of the Earth, making up less than 1% of Earth's mass and volume. Introduction: it forms the surface on which continents, oceans, and life exist. Although thin compared to other layers, it is very important for geological activity. Body: 1. The Earth's crust is the outermost solid shell of our planet, covering both continents and ocean floors. 2. It is the thinnest Earth layer, contributing less than 1% of Earth's mass and volume. 3. The crust is the surface layer composed of rocks, ranging from 570 km in thickness. 4. It is the zone of interaction between Earth and life, forming the foundation of continents, oceans, and ecosystems. Thickness: 530 km in oceanic regions, 50-70 km in continents, up to 100 km in the Himalayas. Density: average 2.7 g/cm superscript 3, Earth's overall average equals 5.51 g/cm superscript 3. Temperature: rises by 30 degrees C/km, 200-400 degrees C at mantle boundary. Composition: sedimentary cover at top, beneath it, igneous and metamorphic rocks. Earth's crust examples: 1. Himalayas, Asia. Thick continental crust, up to 100 km due to collision of Indian and Eurasian plates. 2. Mid-Atlantic ridge, Atlantic Ocean. Thin oceanic crust where new basaltic crust forms by seafloor spreading. 3. Andes Mountains, South America. Continental crust uplifted by subduction of the Nazca Plate. 4. Deccan Plateau, India. Igneous crust formed from ancient volcanic activity. Q2. Differentiate between the continental crust and oceanic crust on the basis of thickness, density, and rock type. Give examples. Definition: the Earth's crust has two types, continental and oceanic crust. Introduction: both differ in structure, density, and rock composition. 1. Continental crust is the thick, light, and granitic part of Earth's crust that forms continents. 2. Oceanic crust is the thin, dense, basaltic part of the crust that lies beneath oceans. 3. The continental crust is rich in Sial, silica and aluminium, while the oceanic crust is rich in Sima, silica and magnesium. 4. Together, the continental and oceanic crust form the outer shell of the lithosphere, differing in thickness, composition, and density. Body: continental crust, thickness, 30-70 km, thicker under mountains. Composition: felsic rocks, granite. Elements: silica and aluminium, Sial. Density: 2.7 g/cm superscript 3. Oceanic crust, thickness, 530 km. Composition: mafic rocks, basalt. Elements: silica and magnesium, Sima. Density: 3.0 g/cm superscript 3. Examples: Himalayas, continental, Pacific Ocean floor, oceanic. Continental versus oceanic crust examples: 1. Himalayas, India/Nepal. Example of thick continental crust made of granite. 2. Pacific Ocean floor, example of thin oceanic crust made of basalt. 3. Andes, South America. Thickened continental crust due to folding. 4. Mid-oceanic ridge, oceanic crust actively forming by volcanic eruption. Q3. Describe the structure of the crust with reference to Sial, Sima, and the types of rocks present. Why is the classification of Sial and Sima considered outdated today? Definition: the crust was once divided into Sial, continental, and Sima, oceanic, layers. Introduction: this classification was based on dominant chemical composition. 1. Sial is the upper part of the continental crust made of silica and aluminium-rich rocks, like granite. 2. Sima is the lower/oceanic crust composed of silica and magnesium-rich rocks, like basalt. 3. The terms Sial and Sima were introduced by geologists to classify the crust on the basis of chemical composition. 4. Sial forms continents, lighter, felsic rocks, while Sima forms ocean floors, denser, mafic rocks. Body: Sial, upper layer, rich in silica and aluminium, felsic rocks like granite. Sima, lower/oceanic layer, rich in silica and magnesium, basaltic rocks. Rocks present: sedimentary on top, igneous and metamorphic below. Outdated classification: seismology and plate tectonics show the crust is more complex, without a strict two-layer division. Sial and Sima. Examples: 1. Granite in Rajasthan, India represents Sial, silica aluminium-rich rocks. 2. Western Ghats basalts, represent Sima, silica magnesium-rich crust. 3. Continental USA shield areas, exposed granitic Sial crust. 4. Pacific Ocean basin, large area of basaltic Sima. Q4. Explain how the crust is related to endogenetic processes like folding, faulting, and volcanism. Give suitable examples. Definition: endogenetic processes are internal earth forces that shape the crust. Introduction: the crust, though rigid, is constantly modified by forces from beneath. 1. Endogenetic processes are internal earth movements caused by forces originating inside the earth. 2. They are geological processes that reshape the crust through folding, faulting, and volcanism. 3. Endogenetic processes result from heat, pressure, and convection currents in Earth's interior. 4. They are responsible for the formation of mountains, rift valleys, earthquakes, and volcanoes. Body: folding, bending of crustal rocks due to compression, e.g., Himalayas. Faulting: cracking and displacement of rocks due to tension/compression, e.g., East African Rift Valley. Volcanism: magma rises through weak zones in the crust, forming volcanoes like Mount Vesuvius. Endogenetic processes. Examples: 1. Himalayas, India. Folding of crust due to plate collision. 2. East African Rift Valley, faulting caused by crustal tension. 3. Mount Vesuvius, Italy. Volcanism where magma escapes through crust. 4. San Andreas Fault, USA. Major fault line causing earthquakes. Q5. The crust is the thinnest and lightest layer of the Earth. Yet it is the most significant for life. Justify the statement with examples. Definition: the crust is the outermost and thinnest layer of Earth, contributing less than 1% of its volume. Introduction: despite its thinness, it is the only layer that supports landforms, oceans, soil, and ecosystems. Body: surface for life, provides land for plants, animals, and humans. Soil formation: weathering of crustal rocks forms fertile soil for agriculture. Mineral resources: rich in coal, iron, petroleum, and other minerals. Water bodies: oceans and rivers exist on the crust. Example: the fertile Indo-Gangetic Plains sustain millions of people. Indo-Gangetic Plains, India. Fertile alluvial soil formed from crustal deposits supports millions with agriculture. Amazon Basin, South America. Dense forests thrive on crust-derived soil, sustaining global biodiversity. Coal fields of Jharkhand, India mineral resources in the crust, power industries and energy needs. Great Lakes region, North America. Water bodies resting on the crust provide drinking water and transport. Conclusion: the crust, though thinnest, is the foundation of all life and resources. Q6. Why is there a difference in thickness between oceanic crust and continental crust? Explain with special reference to mountain systems like the Himalayas. Definition: the crust is made of continental, Sial, and oceanic, Sima, parts, differing in thickness and density. Introduction: the difference arises from composition, density, and tectonic activity. Body: oceanic crust, thin, 530 km, dense basaltic rocks. Continental crust, thick, 3070 km, light granitic rocks. Mountain regions: continental crust thickens due to compression and folding. Example: Himalayas have crust up to 100 km thick due to collision of Indian and Eurasian plates. Reason: convergent plate boundaries cause crustal thickening. Pacific Ocean Basin: oceanic crust is only 5-10 km thick, composed of basalt, hence denser and thinner. Himalayas, India-Nepal continental crust reaches 100 km thick due to compression from Indian plate collision. Andes, South America continental crust thickens where the Nazca plate subducts under the South American plate. Mid-Atlantic ridge, oceanic crust is constantly renewed and thin, 5-15 km, at divergent boundaries. Conclusion: thickness depends on tectonic forces and rock density. Q7. Discuss how temperature and density vary with depth in the Earth's crust. What effect does this variation have on geological activity? Definition: temperature and density both increase with depth in the Earth's crust. Introduction: these variations drive geological processes like volcanism and earthquakes. Body: temperature, rises 30 degrees C/km, 200-400 degrees C near mantle. Density, average 2.7 g/cm superscript 3, increases with depth. Effect: higher temperature melts rocks, magma formation. Density variation creates convection currents in mantle plate movement. Causes earthquakes, volcanic eruptions, and folding. Example: Iceland volcanism results from heat and density variations. Iceland volcanism, high geothermal gradient causes magma upwelling and surface volcanism. San Andreas Fault, USA, heat and density variations trigger crustal stress, causing frequent earthquakes. East African Rift, mantle heat weakens crust, causing faulting and rift valley formation. Ring of Fire, Pacific density differences in subducting plates lead to major earthquakes and volcanic eruptions. Q8. Write short notes on A. Sedimentary cover of the crust, B. Igneous and metamorphic rocks in the crust. Definition: the crust is composed of different types of rocks, sedimentary, igneous, and metamorphic. Introduction: together, these rocks form the lithosphere and control landforms. Body: A. Sedimentary cover, outermost layer of the crust. Formed by deposition of sediments from rivers, wind, and glaciers. Includes sandstone, limestone, shale. Important for fossil records and mineral deposits. B. Igneous and metamorphic rocks, igneous, formed from cooling of magma, e.g., granite, basalt. Metamorphic, formed from alteration of rocks due to heat and pressure, e.g., marble, schist. Provide strength to crust and form mountain cores. A. Sedimentary cover examples: Ganga Plains, India, thick alluvial deposits. Sahara Desert, sandstone layers. Rocky Mountains, USA, shales and limestones. Vindhyan Basin, India, old sedimentary formations. B. Igneous and metamorphic rocks examples: Deccan Plateau, India, basaltic igneous rocks. Sierra Nevada, USA, granite batholiths. Aravalli Hills, India, metamorphic schists and gneiss. Himalayas, marble deposits, metamorphosed limestone.